Hello everyone, this is our MPMC project presentation. Our project title is Snake Game Implementation in 8051. My name is Vineeth. I'm Manoj.
I'm Varun.
Go.
So we made Nokia's oldest flagship game of the Snake game into 8051 game.
So let's go over the architecture of our project. We have 8051 here. It's Atmel manufactured 8089 S52, and we use port 2 and 3 to control the 8x8 dot matrix display, and we use port 1 and 0 for controlling the 16x2 LCD display. And we have two 22 picofarad capacitors and a 11.0592 timer for the operations of 8051, and we also have another capacitor for using the EA pin of 8051.
Let's have a look at a display for the 8051 Snake game implementation. We use a typical LCD program where port 1 is used for the controls and port 0 is used for the data pins. The remaining ports of port 1 are used for controlling the snake in the game for the buttons. We connect the port 2 and 3 set as output ports to the dot matrix display. Initially, all the rows are set to 0 and all the columns are set to 1. When you want to turn on a specific LED such as this, we turn that specific row from 0 to 1 and from that specific column from 1 to 0, so that the current flows from the rows like the high 1 to the 0 and it illuminates the LED. The working of the dot matrix display can be compared to the working of the keypad. We use this display for visualizing the movement of snake, and the LCD is used to display the score.
Okay, so now I'm going to explain about the game mechanics of our project. So initially we'll be starting the game by initializing the game variables, and next we'll be looking forward for the inputs from the buttons. And then if a button is pressed, okay, we'll be determining which directions button is pressed, and then we'll be displaying the snake and the egg on the dot matrix display. And after this process is done, we'll be updating the head based on the current direction and the next direction, which we will be determining using with the button that we have pressed on the breadboard. Then we'll be updating the snake array one by one until we reach the tail. And then now comes the fun part. Now, the way we are going to determine the score is if the head and the position of the egg matches, we'll be incrementing the score. So if it doesn't matches, the code will continue to check if the snake has ate itself. If the snake has ate itself, then the game gets over and the entire process starts over. And if the snake has not ate itself, the loop continues again from checking which directions button has been pressed, and it gets loops over and over and over. Hello everyone, this is Varun, and I'll be explaining how 8051 works with 8x8 display to create those beautiful snake patterns that we saw in the demonstration of the video. So let's go ahead and let me explain you how it all works. So for starters, we know that the display is made up of 8x8 dot matrix, right? So it consists of 8 rows and 8 columns, like as you show in the slideshow over here. Like you can see me right in this slideshow. So we know that it consists of like 8 rows and 8 columns. So in order to light a specific point, light up a specific point in the dot matrix, we need to send a signal such as like 0 0 0 1 0 0 0 0, like for the rows, like which will be our port 2, I guess, and 1 1 1 0 1 1 1 1 for the columns port. So we have to send this specific signal in our ports for the specific LED to light up. So we can use this trick to do some like something crazy, such as, for example, let's say let this be our head of the snake, and let's have another let's say we have the next part of the snake which is next to head, which is over like 0 0 0 1 0 1 0 0 0, and the same thing, let it be second column, like the second LED may locate in like this position. Let's say this is our second LED, so it will be having the same column as our head. So now we can OR these, both of these to get 0 0 0 1 1 0 0 0. So now we can send this to the LED to make it look like both of these LEDs are glowing at the same time. So so this is our basic logic, and this is how we'll be doing. We'll be having data points 1, and let's say data points 2, and let's have another data and another register. Let's say it is R3. That data point 1 and data point 2 will be holding the row addresses of row position of head, and this will be holding column position of the head, and so does the next to head position and next to head column. And R3 will be holding, like, we can choose what we want, like for example data point 1 plus R3 will give access to this one, and data point 1 plus data point 2 plus R3 will give us the access to this one. So we can use this logic to pick whatever LED we want over here. Next comes like how we decide the head position, right? So this is how we'll be deciding the head position. So basically there are 4 buttons, up, down, left and right. So let's say currently the head is located over this position. Currently the head is over here, and I'm going to press the up arrow. So when I click on the up arrow, we know that the head will be going up. So what we can do is we can take the current column port, we can take the current column of the head, and we can move it up. We can like rotate it through right or rotate it through left in order to make the head move up or down, and we can store it in a new data point 1, which locating the row position of the new head, and in data point 2 we can locate the new column position of the head. This is better than using shift registers, because shift registers can't shift across 2 axes, right? It can only shift across a single axis. So yeah, this is how everything works. So okay, so basically when we start the game, the score is set to 0 and the length of the snake is 3, and until we press some button, the snake keeps moving on in the left direction. So let's say I'm pressing the down button, which is basically these 4 buttons. These 4 buttons control each of the directions, which are the first button is down, the next one is up, the next one is left, and the last one is right. So now I'm going to press the down button, and we can look at the snake that it will go in the down direction. See, now it's going on the down, and now let's say I'm pressing on the right, it will go on the right and it will eat this apple.
Cut பண்ணிக்கலாம்.
So now I'm going to press the right button. So as soon as I press the right button, the snake will move on the right direction and it will going to eat this apple over here. So let's do it. Boom. Now we can see that the length of the snake is 4, and we can come and if we go here, we can see that the score LCD says that the score is 10, which means we have eaten 1 apple. So 1 apple is equal to 10 points. So now let's say let's move on the up direction. Now I'm going to press the up button, and the snake is going to eat this apple over here. So now we can see that the length of the snake is 5. Now let's say I'm going to kill the snake, which means I'm just going to make the snake eat itself. So the way I'm going to do it is try and make it of the length so that I can basically make the snake eat itself. So yeah, 1 point is needed so that matches the 8 bits and the snake can eat itself. So, and yeah, now I managed to eat the snake itself, so the game just ended. Yeah, because I got out.
Let's do a cost analysis of our project. Our LCD costed around 120 rupees, and the I2C model which we used just for potentiometer is around like 80 rupees. 8051 costed around 200 rupees, including delivery charge. And this one, first initially we used it without the driver, and it sort of burnt away. So that's a 120 rupees loss. And we bought another one, and along with this, so it was another 120 rupees. So overall, it was around 2,000 rupees. But the thing is that we were using another. When we were using Arduino, the ISP programmer, what happened was we accidentally connected it differently, and it sort of almost killed my laptop, and that's almost like a 20 to 30,000 loss. But thing is that we learned something while doing it, and we learned what and all safety precautions that we have to take, and finally in the end we made our project working. So that's the end outcome. So yeah, that's a cost analysis, and this is we have come to an end of our presentation, and this is our project snake game implementation in 8051. Okay. So this is our project, the snake game implementation in 8051, and we have reached the end of the project presentation. So thank you.
Thank you.